Imagine being able to hop into a time machine and witness history firsthand, or catch a glimpse of what's yet to come. It sparks the wildest dreams. Some might want to travel back to meet ancestors they've only read about, while others would jump forward to see how humanity has evolved in just a couple of decades. It sounds like something straight out of a sci-fi movie, but is time travel really impossible? I dug into this fascinating topic, and what I found will blow your mind, or at least show you the reality behind all those time machine claims. The quest for a time machine is an epic challenge that has scientists pushing boundaries. But so far, it's like trying to crack a cosmic code. They just don't have all the pieces of the puzzle yet. But here's the amazing part: you could be the missing piece. Maybe in your backyard or next door lives, someone who'll revolutionize time travel. Your task for now: listen up and absorb this mind-bending theory, because who knows, maybe it'll spark that groundbreaking idea that changes everything. Imagine being the hero in your favorite sci-fi movie, witnessing something no one else has ever seen, and it all starts with a theory. Time travel might sound like fantasy on screen, but believe it or not, there are real ideas that could make it possible. Let's dive into 3 mind-blowing hypotheses. And first up, we have Einstein's theory of relativity. This genius physicist figured out that if you could move at the speed of light, you could literally jump into the future. It sounds crazy, but here's why. When something moves super fast or is super heavy, time actually starts moving slower for it compared to everything else just chillin' on Earth. Let's put some serious speed into perspective. Imagine going around Earth 10 times along its equator in just 1 second. That's what it'd be like to hit the speed of light. But for me right here, making this video, time passes at a normal pace, about 3 seconds. Now, let's take that idea and blast off into space. Imagine you're traveling near light speed to Alpha Centauri. While you're exploring the cosmos, back on Earth, I'd be hanging out, getting older by the second. So, the question is, would we both age at the same rate, or would time really slow down for the star traveler? So, let's fast forward the time difference we just talked about. 6 years for you on that cosmic journey, and 10 for me back here on Earth. When you finally return home, get ready for a shocking reality check. You'd find out your kids have grown up, the house that was still under construction is now lived in, and the tech gadgets you knew are now ancient relics. It's like stepping into a completely new world, all because of how time works when traveling at incredible speeds or not traveling at all. But here's the amazing twist. Despite the massive time gap for me on Earth, you'd still be young and vibrant, ready to leap into an even brighter future. But what if we could put our aging process on pause? That's basically the idea behind long-term freezing, also known as cryonic preservation. The concept is simple. You get frozen for a long time, then thawed out when technology advances enough to bring you back to life. Sounds like something straight from a sci-fi movie, right? Well, it's not quite that easy. Our human bodies aren't like cold-blooded frogs, and unfortunately, scientists still haven't figured out how to reverse the aging clock yet. So, it looks like freezing time isn't quite achievable, at least not yet. But wait, there are more mind-blowing ideas out there. Imagine being able to teleport information or even physical objects using quantum physics. It's like something straight from a superhero movie. Sounds incredible, but the catch is that grasping the intricacies of this field is an enormous challenge for modern science. Let's pass the torch to future geniuses to crack this code. Among these wild ideas, the first one I mentioned, breaking the speed of light barrier, seems to be our most promising chance at time travel in the near future. Get ready to geek out with me. Renowned physicist Stephen Hawking had some pretty bold ideas about connecting the speed of light to time travel. He didn't give up until his very last book in 2018, where he made one final attempt to crack this code. Let's follow his lead and see where it takes us. Now, you might be wondering, what exactly is the speed of light? Well, buckle up because it's a big number: 299,792,458 meters per second in space or a vacuum. Let's break it down. The speed of light is mind-blowing 983,570,1,056 feet per second, or 299,800 kilometers per second, which translates to an astonishing 186,287 miles per second. And here's the cool part, even with air in our atmosphere, this number doesn't change much. So, we can forget about minor differences for now and focus on what really matters, building a device that can help us harness this incredible speed. The fastest human-made object to date, that would be the Parker Solar Probe, zooming through space at an awe-inspiring pace. What can we learn from its design and technology? The Parker Solar Probe is a powerhouse. It's already reached an incredible 390,000 kilometers per hour or 4,225 miles per hour. But don't worry, by 2025, it'll take things to the next level with a projected top speed of 692,000 kilometers or 430,000 miles per hour. Still, we have to keep things in perspective. This is just 0.064% of the speed of light, which means our spacecraft has an incredibly long way to go if we're thinking time travel. Let's put aside the technical hurdles and the laws of physics for now and tap into that sense of wonder. What would it take to get us closer to making this dream a reality? Imagine if we could boost the speed of the Parker Solar Probe to just 1% of the speed of light. It'd take an insane amount of power, equivalent to 16 probes working in perfect sync at max capacity. But reaching 100% would be mind-boggling, requiring a whopping 1,600 units. Sounds like we've got our hands on a potential time machine, right? Not quite. Let's big explainer some numbers. The cost for one of these projects is about 0.5 billion. Now multiply that by 1,600 and you get a staggering 0.4 trillion. We're talking about an astronomical budget for something that might not even work as expected. But wait, there's more. Let's get real about the challenges. Even if we had that mind-boggling budget, we're still in uncharted territory. We have no idea how this massive project would even work, or if it'd produce anything useful at all. And don't even get me started on safety concerns bong. What if something goes wrong? On top of that, accelerating to the speed of light is like trying to run a marathon without getting tired. You'd need an insane amount of fuel just to get going. But here's the kicker: sustaining that speed would require a fuel supply that's basically infinite. Yeah, good luck with that. You got me there. No space gas stations yet. Now, let's dive into some seriously cool sci-fi stuff. According to the brilliant Stephen Hawking, we might not need fuel at all. Instead, we could warp space-time around us and travel through time using something called a wormhole. Imagine a cosmic shortcut or a tunnel that connects two distant points in space-time. And here's the mind-blowing part with this wormhole. You could potentially zip back to the past or blast off into the future. It all depends on how the wormhole is formed and what kind of ride you're looking for. Buckle up and let's visualize this mind-bending concept. Grab a piece of paper, draw two dots on it, and imagine the time it would take to travel between them. That's our normal reality. Now, here's where things get wild. Fold the paper in half, just like you're closing a book. Instantly, those two dots are connected. The distance is almost zero. That's essentially how wormholes work, according to Einstein's theory of relativity, and they could potentially let us travel vast distances in the blink of an eye. Hold up, we've got an essential ingredient missing in our wormhole recipe: exotic matter. Scientists say that to make this cosmic shortcut functional, you'd need this mysterious substance filling its center. Without it, the wormhole collapses before you can even take a step through. It's like trying to travel a marathon distance in seconds. Since we haven't discovered this strange stuff yet, let's imagine how a time machine using wormholes might work. Send something exotic matter rich into one end of the tunnel. As it travels through, it remains stable, allowing you to follow and pop out at your desired destination. Past or future, who knows? To make a wormhole trip possible, scientists think one end needs to be turbocharged to nearly light speed and then slowed back down again. Talk about an interstellar roller coaster. This concept seems almost too wild for reality, but we're still grasping at the stars, hoping to stumble upon something similar. And guess what? According to some theories, wormholes could actually be hiding in plain sight, nestled between black holes and their cosmic opposites, white holes. Who knew that these mysterious cosmic phenomena might hold the key to understanding how our hypothetical time machine would work? Imagine space-time bending around these cosmic giants like rubber sheeting under heavy weights. That's basically what's happening with black holes, white holes, and wormholes too. The key difference is that a wormhole wouldn't trap you like a black hole does. Instead, it would act as a shortcut for your journey. And here's the amazing part. According to our best understanding of physics, these temporary tunnels aren't even breaking any rules. So, why haven't we found one in space yet? Well, it seems all this wormhole talk might actually be more about time travel than just hopping from point A to point L. And yes, that's correct, traveling into the future is exactly what these theories are hinting at. You're right, I was wrong earlier, wormholes could indeed be our ticket to visiting the past. However, let's not get ahead of ourselves here. We've got a long way to go before we can make interstellar travel a reality. As it stands now, there are no confirmed wormhole candidates in space that we can use for time-traveling adventures. But here's the cool part: we don't need a spaceship or even leave our planet to explore the past. Just step outside and gaze up at the sky. You're already seeing the light from distant stars and planets that's been on its way to us for years, effectively allowing you to witness their past in real time. It's like having a cosmic history book right above your head, with every twinkling star telling a story of what once was. The light from other planets and stars takes an insane amount of time. We're talking hundreds, thousands, or even millions of years, to reach our planet Earth. So when you gaze up at those twinkling lights in the sky, keep in mind that what you see is essentially a flashback from way, way back. And while we're all about exploring and understanding this cosmic phenomenon, scientists are working tirelessly to unravel the mysteries of space and time itself. Thanks for joining us on this intergalactic journey. Don't forget to hit that like button if you learned something new today. Your support